Hi everyone, welcome back. The learning goal for this video is to use the energy values to calculate the kilocalories or kilojoules for food. You can see in this example here that 1 hour swimming uses 2,100 kilojoules of energy. So nutritionists burn food in a calorimeter that is used to measure heat transfer. And a calorimeter consists of a steel container filled with oxygen and a measured amount of water. And it indicates the heat gained by water, which is the heat lost by a sample of food during combustion. So once again, in a calorimeter, the burning of a food sample increases the temperature of the water because a combustion reaction releases heat energy. And therefore, that increases the temperature of the water, which is used to calculate the energy value of the food in calories or joules. Here's a picture of what a calorimeter looks like. So once again, the food sample is in a sealed container. There are some ignition wires in the presence of oxygen, and we will learn later on about combustion reactions, which once again release heat energy. So once the sample of food is burned, let's say you have an almond in there and you're burning it and you want to figure out how many calories are in that one almond, then the heat released from that combustion reaction is transferred to the water, and we measure the transfer of that heat energy using a thermometer. We see how much or how hot does the water get after the sample of food has been burned by combustion. And then also there's a stir in there to make sure that the heat transferred is dispersed homogeneously throughout the water when we measure that final temperature. We're just not measuring one localized spot that's been heated, but the water is being mixed throughout. And so whenever you purchase, like for example, some crackers here, if you look at the label, you'll find the nutrition facts. And energy is shown as the nutritional calorie, big C calorie, which actually stands for 1,000 calories or 1 kilocalorie. So even though you're used to probably hearing like 130 calories, you might be thinking little c calories, but no, it's big C calorie. It's that number times 1,000 actually. And in countries other than the United States, energy is shown in kilojoules. The caloric or energy value for 1 gram of food is given in kilojoules or kilocalories once again. And the typical energy values are different for each type of food. And so you may be familiar with the idea of macronutrients, such as carbohydrates, fats, and proteins. Well, it turns out we get a different amount of energy from each type of food. So for example, if I eat 1 gram of carbohydrates, I will get 4 kilocalories of energy from that food. Fats, you get 9 kilocalories per 1 gram, and protein, you get 4 kilocalories per 1 gram. You will be provided this table on an assessment, but what I would love for you to be able to do is be able to utilize these values to calculate the energy value for different types of foods that contain, all of the macronutrients, carbohydrates, fats, and proteins. As you can see here, and not all foods contain all three, like an apple, for example, contains carbohydrates only. And so you would take 15 grams of carbohydrates and multiply it by that conversion factor of 4 kilocalories per 1 gram of carbohydrates. And then you would get 60 kilocalories total. But you can see, for example, beef has no carbohydrates, but it has both fat and protein. And so all of these are different examples of the types of foods you may eat and then their calorie content. So when you're asked to calculate the energy from food, once again, always with problem solving, state the given and needed quantities. Use the energy value for each food type, carbohydrates, fat, or protein, and calculate the kilocalories or kilojoules, round off to the tens place. So you don't have to stress out about significant figures here. Will report the answers to the tens place. Add the energy for each food type to give the total energy from the food. So for example, you would have to do the calculation for beef, for fat separately, since fat gives us, for example, 9 kilocalories per 1 gram. And then you would have to do the other calculation for protein separately. And then you would add the total amount of kilocalories from fat and protein together to get the total energy for 3 ounces of beef. All right, go ahead and try to do this one on your own and then come back and check your work with me. All right, so we have a cup of whole milk contains 13 grams of carbohydrates, 9 grams of fat, and 9 grams of protein. How many kilocalories does a cup of whole milk contain? And we will round our final answer to the tens place. So once again, always write your given. You have 13 grams of carbs. I'm going to abbreviate that as C, 9 grams of fat, and then 9 grams of protein. And we need how many kilocalories? So the total, I'm going to abbreviate that as Q because it's still heat energy, still energy unit, and say Q total. So we need to find the energy from each of these separately. So for example, and then I would provide the conversions for you. So I would provide this table on any assessment or within the context of the problem. It looks like this question's asking for kilocalories, so I'm going to focus on these numbers here. If the question was asking for kilojoules, then I'd focus on these numbers here. So I'm going to go ahead and write those down to help us solve this problem. So for carbohydrates, it's 4 kilocalories of the carbs over 1 gram of carbs. For the fat, it's 9 kilocalories of fat for every 1 gram of fat. And for the protein, it's 4 kilocalories of protein for 1 gram of protein. Because each of these has different values and different conversion factors, we will have to do 3 separate calculations before we solve for Q total. So I'm going to start with the carbohydrates. So 13 grams of carbohydrates, and I'm going to draw my ladder here. And 4 kilocalories of carbs over 1 gram of carb. And so in doing the dimensional analysis, grams of carbohydrates cancel out. And so we take 13 times 4 and we get 52 kilocalories. But remember, we're always going to go round to the tens place for calories or for any kind of nutrition calculation, whether it's in calories or joules. So I'm going to abbreviate or to round it to 50 because this is the tens place here. And then I'm going to do a same type of calculation for fat. So 9 grams of fat, but remember the conversion factor for fat is different. So 9 kilocalories of fat for every 1 gram of fat, and that's going to be 80 kilocalories. Technically it's 81, but I'm going to round that. So 80 kilocalories there, round it to the tens place. And then the last one is 9 grams of protein. And the protein provides us 4 kilocalories of energy per 1 gram of protein. So grams of protein also cancel out. So you would say 9 times 4 is 36, but we're going to round to the tens place. We'll round it to 4 kilocalories. So it's okay to round in the middle of the calculation here. Nutrition is not exact, and you'll even see that on the labels of the foods you buy. So we're going to go ahead and keep to that, rounding to the tens place. And then Q total, I'm going to go ahead and erase this here so we have some space. So our final calculation is Q total is equal to the energy that comes from the carbs plus the energy that comes from the fat plus the energy that comes from the protein. So that's 50 plus 80 plus 40. So 50 plus 80 plus 40, and that's 170 already in the tens place, so we're good. Kilocalories. So what that means, once again, this whole calculation helped us to determine the amount of kilocalories in 1 cup of whole milk, which is about 170 kilocalories. And so many of you may be interested in nutrition and health, or you may be studying to become a nutritionist. And so this is going to be part of your everyday life. The number of kilocalories or kilojoules needed in the daily diet of an adult depends on gender, age, and level of physical activity. And for a person to lose weight, then the food intake needs to be less than the energy output. And so once again, it's not just about the food we eat, although that's a huge part of it, our nutrition, right? But also it's about how active we are. And you can see, the different types of activities and the amount of energy expended, which is also dependent on the weight and the age of the adult. And then once again, the amount of recommended calories based on gender and age and activity level. Well, thank you for watching. And as always, email me with any questions.